Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
If he wants to prove it, we can prove it actually. See here what is happening actually in this diagram. This link is of 100 Mbps. This link is of 10 Mbps. So the default cost of loopback interface is 1. The default cost of loopback is 1 and the default cost for 100 Mbps will also be 1 and default cost for this 10 Mbps will be 10. So 1 is for loopback, 1 is for this 100 Mbps and then 10 for this 10 Mbps link. Total cost will be 12 to reach R5. Because if it goes, you see R1 can also reach the loopback of R5 via R3 as well as via R2. But the shortest path will be this. Because here you are having Ethernet connections, whereas for serial interfaces by default cost is what? 64. That is why for R1 its best path to reach the loopback of R5 will always be via R4. R1 will go to R4 and then R4 will send that information in the direction of R5. But to reach R6, both links are serial links. That is why cost is higher to reach the loopback of R6 from R1. You see? So this time it is here its cost is what? 64 here. So 64 plus 1 plus 10 is what? 75. Hello. Even you can also check it on R1 as well. So IP route OSPF. Check it out. 75 and 12. Any problem? So now that is why for BGP its best path is via, check it out, R5. Done. Now to solve this or to prove it, what can we do? We can configure here its cost on F2 by 0 as 65 actually in place of 1. On R4 I will modify its cost of OSPF, right? So that the overall cost from R1 to reach the loopback of R5 will get changed. Now it will become higher than via R6. But you have to do this configuration at the end of R4's F2 by 0. Because if you move on R1 and if you change it on R1's F0 by 1, then it will get changed for both networks, for the loopback of R5 as well as for the loopback of R6. So you have to do this modification in that manner so that the effects will be only for the loopback of R5 only. Fine. See. Oh, we have not made any change on R4 yet. So go to F2 by 0. IP SPF cost is what? Make it 65 now. Here. Now you move back again on R1. Check it out. Just wait, it will take some time to synchronize. See. Via R5 its cost is what? And via R6 its cost is what? Which one is best now?
R6.
Via? Tell me. Is not it? And if it is also same, then what will happen? Let's make it same now via both neighbors. Let's move on R4's F2 by 0, make it 64 itself. So let's move back again on R4 and configure its cost is at 64 now. Move back again on R1, open, just wait for a moment. Via R5 also its best path will become via S75C. So this time ICP cost to reach next stop is also same. What is next tiebreaker now? Oldest path. But this oldest path works only for eBGP neighbors. This time R1 is having
So router ID.
Exactly. R1 is having only and only IBGP neighbors, not EBGP neighbors. So this oldest path tiebreaker will work only in that case when you are receiving prefixes from your two different EBGP neighbors. But this time, of course, it will not take place, right? Next is what?
Router ID.
Lower
Router ID.
right. See, its best path is via R5. You can see here. So who is having lower router ID, R5 or R6?
R5.
How can you see here router ID? How can you see your router ID? Because this time next hop address as well as router ID is common. So how will you be able to see that what is your router ID and what is your neighbor address? See, remember, I'm again telling you, this is your next hop address. This is what? Next hop. And this is the metric to reach this next hop, right? Then this is your neighbor address, this one. This one is your neighbor address. And this is your neighbor's router ID in brackets. In same manner here, this is next hop. This is the ICP cost to reach next hop address. This is your neighbor address and this is your neighbor's router ID.
So what it will happen if you put same router ID?
Yes. Next is what? Lowest neighbor address. So now do one thing to prove it actually. See, this time based on lower router ID, it has defined its best path via R5 because R5 is having lower router ID than R6. Compare it. Hello.
Yes.
Of course, R5 is having lower router ID. You do one thing, move on R6, configure its router ID lower than R5.
Then R6 will be lovely.
Configure its router ID lower than R5. So let's move on R6 now and say BGP router ID. This is the command to configure BGP router ID, right? And make it 6.6.6, which will be lower than 150.1.5.1. Now move back again on R1. Let it synchronize first. See, its best path is now via R6. Check it out. Hello. Of course, based on lower router ID, it has proved now, right? And then after proving this mechanism of router ID, let's go for lower neighbor address, right? So for that purpose, I have to configure same router IDs on both devices, right? So let's do one thing. Because on R5 its router ID is 150.1.5.1. Let's configure the same router ID on R6 as well. Let's move back again on R6 and say BGP router ID is 150.1.5.1. So this time for R1, both of them are having same router IDs, R5 as well as R6. And now you can see that best is via R5 because R5 is having lower neighbor address than R6, and it cannot be same. Two different neighbors cannot have same IP addresses. Can they have?
No. Yeah.
Tell me. So this is the BGP path selection process. So finally decision is made based on
Neighbor.
exactly. See, this is the way in which BGP selects its best path. Fine, that was good. Now let's talk about BGP path attributes. I mean, let's manipulate path selection with using BGP path attributes, and I'm going to start it from wait. This is customer actually R1, and this customer is having two different customer edge routers, R5 as well as R6. The whole traffic is going via R5 now. However, let's do one thing. Let's change their router IDs now. Let's move on R6, and on R6 let's make it 6.1 itself, right? But again, you will see that based on router ID, again the best path for R1 will be via R5 only. Just to see via R5 for all prefixes. It means if you check its routing table, so IP route BGP see its best path is what? I mean its best path is via R5. Right? This is the problem. This is problem actually. You know how? Because if you are having two different connections actually, like you can reach internet via R5, you can reach internet via R6 as well. But your entire traffic, your whole traffic is going via R5 only. There is no load balancing actually. Are you getting my point or not? And one more thing that I would like to show you over here before going to modify it to wait. Let's move back again on R6, and for R6 it is learning prefixes coming from BT only. Is not it? In case if R6 lost its reachability with its neighbor, you can shut down your neighbor in BGP, right? That's called graceful
Shutdown.
and this feature now they have introduced in OSPF as well, but in iOS 15 only.
Version.
I discussed it with you. So now it has gone down. It should have received these prefixes now via R1. Is it receiving these prefixes coming from R1 now? See, that's the problem now. There is no advantage of having redundant link. How will you solve this problem? And this is your logical topology now. See, now you have two solutions. Either configure IBC peering in between R5 and R6 as well. That's not allowed over here. However, you can configure it, but it's not allowed. So what will you do now to solve this problem? Are you getting my point or not? Have you understood the problem or not? See, R6 has lost its internet connection. Now the lane users behind R6 are not capable to reach internet. However, it should have reached internet via R1, because R1 is receiving prefixes coming from R5 and R6 is still having neighborship with R1. So R6 should have reached internet via R1, but it cannot due to IBGP rule. Due to IBGP rule. So to solve this problem, what can you configure? You can configure this R1 as route reflector. So you do one thing, configure this R1 as route reflector and configure this R5 and R6 as a client. So of course now route reflector can exchange prefixes in between two different clients. So do one thing, move back again on R1 and configure router BGP 65500, say neighbor 150.1.5.1 and then neighbor once again 150.1.6.1. And now see, move back again on R6. On R6 show IP BGP sorry, neighborship have not came up yet. Still it is in active state with R1, right? Just wait for a moment. Now it have came up, right? And you see show IP BGP. It have also received all these prefixes coming from not from R5. That's the problem. Prefixes are coming actually from R1, but next hop is unchanged.
Once IG.
Hello, that's the another rule of IBGP, that whenever a BGP router will advertise any prefix towards IBGP, it will never update its next hop address. And this time next hop self command cannot be configured on R1. Even it is not required. And this is good for us actually, that it didn't modify its next hop address. That's good. See, as I said previously in BGP when I was explaining to you that this is actually a good feature. This is one of the good feature of BGP, that for IBGP it does not modify its next hop address. And now I will prove it, that why is it good for us that BGP do not modify its next hop address for its IBGP neighbors only. See, its next hop address is still what? R5's loopback. And internally you are running what? IGP. So whenever you will try to transmit traffic in the direction of 100.0, it will not go via R1. It will not go via R1, it will directly go in the direction of R5. See, this R6 has installed these prefixes inside its own routing table. So whenever it will require to transmit data towards all these prefixes like 100.0, 101.0 or 102.0 or 103.0, it will directly transmit that traffic in the direction of R5 now. Traffic will never traverse via R1. Traffic will never go via R1. However, this R6 is receiving these prefixes from R1. Try to understand. R6 is receiving prefixes coming from R1, but traffic will be forwarded towards R5 due to next hop, because remember, your router will always transmit your data based on next hop address only, because router always performs routing lookup in its routing table just to know its next hop address. It's not it. So this time whenever from R6 you will try to reach an internet, your traffic will go directly in the direction of R5. It will never go via R1. This is the advantage of do not modify next hop address by BGP for its IBGP neighbor. Have you understood it or not? If IBGP would have modified its next hop address, what could have happened? Traffic will start to go in the direction of R1, and then R1 will send it back in the direction of R5, and unnecessarily latency will be higher. Your bandwidth consumption will be higher. Understood or not? Because in BGP you can form neighborship in between two indirectly connected devices. That's what happening here actually, that R1 and R6 are having neighborship. However, they are not directly connected, but IGP is running over there. See, next hop must be reachable. So from R6, of course, R6 can easily reach the loopback of R5, because when R1 is giving these prefixes, see, move on R6 actually and open. However, by looking at this BGP table, it looks like it is getting these prefixes coming from R5 only, right? But if you open it in more details, 100.0, its next hop address is this, coming from neighbor this, and this is the neighbor's router ID. Understood or not? Do not read originator cluster list. We'll be discussing it later on during the advanced route reflectors actually, right? Now, in case if neighbor comes up once again now, neighborship will come up, and once again this R6 will start to receive these prefixes coming from, check it out, R1 as well as BT. Now, its best path is via BT. Check it out. Why? Again, you have to discuss it with me. That why this R6 has defined its best path via BT only, not via Esprit or something else. First of all, what will it check first? Next hop. Whether it goes via BT or via R5, next hop addresses are reachable. You can try to ping it like 150.1.5.1 as well as ping 201 100.100.1. see, so next hop addresses are reachable now. See, next is weight is, tell me, will it be possible for BGP to define its best path based on weight now? Tell me.
It is same, so not
No, because it is 0, same. Next attribute is what? Local preference.
same.
No, it is not same. Via BT,
No.
it is null.
Yeah.
Whereas via BGP neighbor alpha, it is what? 100. Remember, always remember that if you are not receiving any local preference, I mean, if your local preference is null from one of the neighbor and from another neighbor it is receiving default local preference, then also it will not consider local preference, or it will not define its best path based on local preference. If it was happening, I mean, if it was considering the local preference, then of course it should have selected its best path via R5 only, not via BT. Remember that if local preference is nothing, is blank, then also BGP considers it as 100. Actually, it considers it as what? 100 if it is blank, if it is not mentioned. So by default it will consider it as 100, and now via both neighbors it will be what? 100. So it will be same. See, try to understand this local preference in this manner. Like if you are receiving default local preference from one of the neighbor, and from another neighbor you are receiving null local preference, nothing, then it will not compare its local preference. That's it. That's what I wanted to show you, or I wanted to tell you, right? So this time from one neighbor it is receiving 100, which is default local preference. From another neighbor it is not receiving anything, so it is not gonna to compare their local preferences for their best path selection. Because as I said, that if it is not receiving any local preference from one of the neighbor, then it will also consider it as 100. So actually it will become same. It is not like it is not considering local preference. It is considering, it will consider it. But do one thing, via R5 make it 101 now. Via R5 make it what? 101. Okay. Whereas via BT its local preference will remain as null. Okay. But you will see that it will start to preferred via R5. Okay. Because what I said, that if it is null it will consider it as 100 only. So this time it is not possible for BGP to define its best path based on local preference. Next will come as AS path attribute. Self-originated, forget about it, right? AS path attribute. Via both neighbors it has to across two ASs only. So of course it's not possible for BGP to define its best path based on AS path attribute. Next is what? Origin code. Is I, same. Via both neighbors. See, after AS path. Then med is also same. Via one neighbor it is 0, via another neighbor it's nothing. If it is null, then also it will consider it as 0. And remember, lower is always preferred in case of mat, right? Next attribute will be external over internal. See, via BGP neighbor it is what? Internal. Via BGP neighbor via BT it is having external. See, which one is preferred? That is why external is best now. See, check it out. So external will always be preferred over internal. Via R5 you see I is there, but via BT there is no I. Tell me, is there any problem now? So for R6, its best path is via what? BT. So it is necessary in BGP that you will always advertise your best path information towards your neighbor. You will always advertise your best path information towards your neighbor. So this time it is going to advertise this its best path information towards its neighbor, and it is having neighborship with R1. So it will advertise this information towards R1 that you can reach these prefixes via me. That is why R1 is receiving these prefixes from both neighbors. Because for R5 its best path was via BT. For R6 its best path is also via BT. So both of them are advertising their best path information towards their neighbors R1. And R1's best path is what? Via R5. That is why this R1 is giving this information back to R6, that you can also reach these prefixes via me as well. Hello. See, this time because you have configured route reflectors, right? So it is mandatory for BGP that it will advertise its best path information towards its neighbor. So for R1 its best path is via R5. So it is mandatory, it is compulsory for R1 to advertise its best path information towards its another neighbor. So yes, R1 is having neighborship with R6 as well, so it will also advertise this information towards R6. That is why R6 is receiving these prefixes coming from both neighbors, eBGP as well as iBGP. However, you can move back again on R5, and on R5 you will be receiving prefixes from its eBGP neighbors only, not from its iBGP neighbor. See, this is R5. It is receiving these prefixes coming from its eBGP neighbor only, Sprint US as well as BT. It's not receiving this prefix information from R1, because for R1 its best path is via R5 itself. So why will it advertise this information back towards R5? Hello. Try to understand. For R1 its best path is what? Via R5. So why will it be possible for, why will it advertise these prefixes information back towards R5? So it will advertise its best path information towards another neighbor, which was R6. So it has advertised this information towards R6, and R6 was receiving these prefixes coming from R1 as well as via BT. For R6 its best path was via BT. That is why it is also advertised its best path information back towards R1. That is why R1 is receiving these prefixes coming from both neighbors.
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.